on the increase in our volume, but we're still going to get the same solubility, which is why we can say solubility is what type of property? Characteristic property. Okay, here's our units. What does this look like?
Density.
Yeah, kind of looks like density. Not the same thing, not exactly, but it does have the same unit. So be careful when you're taking a look at that, okay?
Saturated brine.
All right. Concentration. All right. So concentration is how much solute is dissolved in a solvent. Okay. So the mass of our solid dissolved per, what is this? What's another way of expressing this? Say it again. Okay. Of liquid. Okay. And so solubility is the maximum concentration. So this picture is depicting what we call a concentration gradient, where we go from something that's diluted, there's not a whole lot in here, to something that's like concentrated, where we can't even see through it, the color is super dark. You can use your powers of observation on this particular solution to go, okay, this is really weak, and that's really strong, or this is really diluted, and that is really concentrated. Does that make sense? All right. So turn to your battle buddy. Explain to them what, in your words, what concentration is. All right. Say it. In your own words, what is concentration?
How much of the solvent how much of the solute is in the solvent?
I mean, it's there, but. All right. So a saturated solution. Let's take a, let's think about that picture of where it was diluted all the way to concentrated, and let's talk about saturated solution, right? So a saturated solution is a solution where no more solute can be dissolved into the solvent. And if we try to put more than that solvent can take, it comes out, it precipitates out, and it forms this solid at the bottom. And this is called a precipitate. So if we have a diluted solution, are we going to have any of this stuff at the bottom? No. If we have like a concentrated solution, like all the way to that like dark one, and we add more solvents or solute to that solution, do you think this stuff will start coming out?
Yeah.
Mm-hmm.
I would.
So what's a precipitate? I just gave you a definition. Turn to your battle buddy. What is a precipitate?
It's like the solid liquids. Excuse me.
I like that. Mila said from 8th grade science, it's the stuff that's left over. Up here on the board, it said the precipitate is the solid that's left over that has not dissolved into the solvent. That's it. If I were to take sugar and I mix it into water, what is my solute? Turn to your battle buddy. Tell your battle buddy.
Mm-hmm.
All right, Crown.
When I was a stupid little kid,
Story time.
What?
big bowl.
Okay.
And I knew what salt was, but I wasn't something I come across often, me being a super fine little kid.
Okay.
And she had this big bowl, right,
Okay.
of water, and at the bottom, I see what looks to be sugar. Little to my, like, greatly to my surprise, it was salt. So me, I had stuck my finger in there,
Mhm.
and like, this is at the maximum solubility.
Okay.
of the liquid.
Okay.
And so I ran out of there and like my face was puckered up so tight, like I was gagging. 'cause
Oh, so you drank this solution?
Yes,
Oh, nice.
that was fun.
All right, yeah, that would be great. So what is the sugar in this particular solution? What is it? It's our solute. Okay, and what's our solvent?
Water.
Now, if we make sugar water, does anybody know what you can do with a supersaturated solution of sugar water?
Freeze it.
Yeah, you can give some of it to the bird. We'll talk about supersaturated solutions a little bit later, but if I have a supersaturated solution, you can do that. But as the chemistry students have like just tried to convince me, you can take a supersaturated solution of sugar water and make rock candy.
What?
So you can take a supersaturated solution, and again, I'll talk to you guys about this. And it's basically where you force more solutes to dissolve in your solvent than would normally be okay. And then you put a piece of string in there, and the string causes a reaction in that solution that causes the formation of sugar crystals, and you get rock candy, and it's super cool. All right, I've given you guys some base information. I want you to calculate the concentration of 35.6 grams of solute dissolved in 241 milliliters of liquid.
Yes.
Well, guess who's gonna go to the board and like right out the equation? Because she's super awesome and I love it. Yeah, so I know you guys are gonna ask me, Miss Wiley, do we have to do sig figs? CJ, do we have to do sig figs?
Yeah.
Cadence, do we have to do sig figs? What would I say?
You would say no because you're a nice person.
I would actually say always and forever sig figs. And Mila's making a face at me. Oh, I think you can, be nice to me. I gotta.
No, because you're a nice person.
I'm a sig fig.
Always and forever.
Okay, thank you. Yeah.
I take that.
Really? Yeah. How big was two? Just like one of those tiny tubes?
All right,
Oh my gosh.
let's take a look. Did we all do this with our battle buddies? 0.148 grams per milliliters?
Yeah.
All right. Concentration equals mass of solute divided by mass, volume of solvent. We set up as a ratio. And there's our concentration. Awesome. Do another one, because these are fun, right? Calculate the solubility of a saturated solution, which is made of 42 grams of solute and 850 decimal milliliters of solvent. Now,
You good?
all right,
Yeah, I got something.
you got an answer for me.
I do.
I know you do. You do? Write your work up on the board.
I think I did it right.
All right, here's what I'd like to ask you to do right now, since we're gonna like throw this stuff up on the board, and I know you guys all have answers. Turn to your battle buddy, explain to your battle buddy again, what is a saturated solution?
It's the max amount of solvent.
All right, now ask yourself, are there any crystals at the bottom of our saturated solution? If it's at full saturation, we haven't overdone it.
No,
Is there anything at the bottom?
no, it's almost there. You overdid it. And you're perfect.
Perfect, all right. If you accidentally got large particles of solute in your E-dish before evaporating, what was that time?
It affects your mass.
Does that make sense? So it affects your total mass of the solute that came out of solution, right? Okay. So if I ask that question for your lab, I say, hey, what errors could you have made that messed up or skewed your results? Is that one of those errors that might be included in there?
Yes.
And then you guys can explain how it skews your results? All right. All right. And there was a little bit of confusion about this, and I was wandering around, so hopefully it was cleared up. But how do you know that you have a saturated solution? Go ahead, Kai.
When there's precipitate at the bottom of the test tube.
So if I mixed my solution and there was nothing at the bottom, can I be certain that that solution was saturated?
No.
No. Thank you, Steve. All right. Was there a substance you guys were dealing with that was more difficult to dissolve than the other? Which substance was it?
The little ball. You have B.
So B?
Hey,
Okay. So not all solutes are equal. All right. This one should be easy. What was the first thing you masked? Okay. Why would we take an E-dish plus cover with nothing in it? Why did we do that?
So we can get our solution.
Hold on. I hear a lot of talking.
So we get our solution dissolved in solid.
Okay. Do we all agree with that? Because we didn't do what? I saw that some people tried, but what were we not massing in the beginning? What was it that we created without actually like taking measurements?
Solid.
The solution. Because all the data that we needed was going to be from what? If we said at the very beginning of this conversation that solubility was a characteristic property, right?
Right.
Then it wasn't dependent on what? What's the other word for quantity if we're talking about liquid? Guys, over here. What was it not dependent on? Guys, say super loud.
Volume.
So it didn't matter what volume we took, right? Which is why I told you only did a very little bit to evaporate out of your dish, right? Okay, so all the information we need to calculate solubility is based on what was actually dissolved in our solvent, right? All right, so check it. You guys now know what the mass of your solute is, right?
Yes.
You guys know what the mass of your solution was, right? And then you also know what was the third piece of information that we had to calculate. What's the third piece that we had to calculate? All right, guys, stay loud.
The volume of the solvent.
Well, we start with the mass of the solvent.
Yeah, then you have to calculate the volume.
All right. Say it real loud, Kai, because you got it.
You have to calculate the volume of the solvent from the mass of the solvent.
Did you guys hear that? If you didn't hear it, then you need to. Because we're given a bunch of masses, right? What are the units of solubility? So how the heck do we get our mLs? But did you put full 5 milliliters of water in your E-dish? No way, Jose. So we're given the mass of our solvent, or our solute, the mass of our solution, we can take those two pieces of information and calculate how much solvent we had. What the heck is our solvent? What liquid did we use to make our solution? And what piece of information can we use about water to change from grams to milliliters? What is that? What's the name of it?
Science.
Say it loud. Say it super loud.
Density.
Yes. So you guys are also going to have to use density to change the mass of your solvent so that you can calculate your solubility. You all get that? I want to see some thumbs up in the air that you guys understand what we just discussed. All of them. All the thumbs. Yes. Those of you that are done, I hope you snapped yourself out. Those of you that aren't, let's finish up so we can get a snap.